Hello again. It was a long video, the previous one. It took like 55 minutes. So this is the third video, and here I will make a short video so that I can introduce what the fuse bits are, how you use the ProgISP like program software for downloading the code into your program. What is this microcontroller? And the important thing is here that pay attention to the fuse bits so that you don't lock your your microchip, the MCU microcontroller. If you lock it, then we have to put it away. Later, with different tools, it's possible to reach it and unlock it, but the reset bit. But if you, we cannot do it. It will take a lot of works, and we need to order new tools like some Dr. Fuse, some kind of thing like that, to order it, and so that we can reverse the fuses. So please pay attention. I will just show how you run the what is ProgISP. ProgISP is, right now I have my programmer connected to the Atmega32 to the board. So I will download a code to the Atmega32, but the process is the same for Atmega 8. So I will show both of them here. What is the interface of Atmega 8? What is the interface you will see the fuse bits for Atmega 32? And then I will just select Atmega 32 for uploading a code. Let me show. Here is the code that in the previous video we made at 8 test, but here I have made another code for Atmega 32. I made the name passive buzzer 32 and the pin B0 is connected to that. So this, we will not see the code for it, we just see the hex file and how to upload it, to download it to the program, not the microcontroller. As you see, this is the icon, the executable file for the ProgISP. I click on it. I want to see where it will appear. Here it came. No, I don't need this anymore. There's this kind of interface you can see. And here is some kind of weird things. Don't worry about it. It's just the format, that font that the computer doesn't have. So it shows like that. Here, first thing, you select your Atmega 8 microcontroller, and then after that you see there's a lot of like boxes here that you can click or not. One of them, like program flash, like chip arrays, we want it to be done, and program flash, that like to burn the program to the chip, or what is this? Copy it, download it. It means that. Then the other things I've never used, basically program EPROM only, pre-written views. I have not changed down. I don't use them, so we just use this chip arrays and program flash. And the other thing we will use here is program fuse, so that we will verify flash is by default on, but program fuse we turn it on. And after that is done, you see USB ASP. We have to click on this so that we are sure this is selected, not this other one. So this we click on it. This is selected. With the load flash, you go to the address that you have the file on. Now I have the two different files. for Atmega 8 and Atmega 32. Right now I put Atmega 32 because my microcontroller is Atmega 32. I don't want to download Rhine code to the Rhine micro. This is done. Then the most important part is this fuse bit. Let me show this 3 dots. You click on it. Here comes, you need to set and configure the fuse bits that your micro has. Right now, this is the fuse bit of the Atmega 8. Here is selected Atmega 8. Here is shown all the fuses that Atmega 8 has. What they mean, we will learn this in detail, what these fuses mean. But so far that is related to us is check cells here. Clock select 0 to 3. These 4 bits, you need to select it in a way that it gives you 8 mega. You remember in the program we selected 8 mega bytes internal, 8 megahertz internal clock. So here also, if we use this check cell 3, clock select 3, 0, 1, 0, and 0, this will give us 8 megahertz internal. And let me show where I get that. This is the data sheet of the Atmega 8. Where can I see? Yeah, AVR Atmega 8 microcontroller data sheet. And the page number right now is the page 30. There's a table, internal calibrated IC oscillator operating modes. Here says check cell 3 to 1. If they are like this, 0, 0, 0, 1, it will be, you see, internal calibrated RC oscillator. Nominal frequency that I will get with these values will be 1 megahertz. If I put this one 2 megahertz, if I put this 4 megahertz, there's no 3. And if we put in this one, we get 8 megahertz. Let's say here that if you want, for example, to have a 3 megahertz working speed, you cannot do it with the internal oscillators. You need to use external crystal for clocking your microcontroller. So you will not use this anymore. You will use another configuration that will use not this one. You will use the same the registers for clock selection registers, but with different numbers. Right now, this one binary number of 1. This one is the binary number of 2. This one is the binary number equal to 3, but it's just the third option. The value of the frequency will be 4. And this one is the binary number of 4. And the fourth option is the 8 megahertz. We have, with these 4 bits, we can count up to 8. So we can have 4 more, is it 8 correct? Yeah, 8, up to 15, up to 16, yeah. We can count up to 16. So this is the 4 first configurations. We can have 12 more configurations with this 4 bits. 2 times 2 times 2 times, yeah, 8 times 2. 16 configurations we can have with 4 bits. So we will use this configuration to be 8 internal. That is what we are selecting here. 8 internal. So if I make this, for example, this one check cell 0 to be 1, it will be 1 megahertz. But I don't want it, so I want 8 megahertz. And the important thing about the reset disable, you see this one, reset disable, it must be 1. If you make it 0 and program the program your microcontroller, it means you will lose the reset pin, and reset pin is important for being able to program the microcontroller. So if it is like deactivated the reset pin, then you will not be able to program it anymore. So you should make sure that this is 1. This one is 1. The fuse bits are like as it shows here. All the others we are not even touching. But right now I would just if my chip was at Mega 8, I would just close this. I am sure that this is 1. It's okay. And this is 8 megahertz. I close it. This is closed, and then I press program. It would program my code. But my the code, that hex file that I have, is for Atmega 32. So I will just go here, check the Atmega 32A. I will find it. This one. And pay attention, please, that all other things are same, but if I go to the fuse bits are a bit different. This one doesn't have reset disable. This one instead has G tag and spine. They are different fuse bits, but luckily the check cell is the same. Clock select, if you put 100, you get the same. It's not the case for all of the AVR microcontrollers, but Atmega 8 and Atmega 32A have the same, only in this one. In the other frequency levels, they might have different. Only this one, they have both 0, 1, 0, 0 will give me internal 8 megahertz. So I check it, everything is okay. Then I load the program. I'm sure I make sure that it is that. Again, I make sure that this one is clicked, and if I press the auto, this walking guy here, the program will be loaded to my programmer. Let's do. You can see a bar field here and says erase is done. Here you can see the report, reminder, collect readme, and everything process to use it. It means everything is okay, it's done. If you have not locked your, if you have not messed up the clock select, you haven't selected external clocking source for your system, you should be able to program it over and over. I can press this as many times, and every time it says here ready. It means the programming is done. But if you, for example, if you make this one clock cycle here 1, I'm not making. If I put it 1 and close it and then press the auto, this will make, I'm closing it. I don't want to look for an external crystal right now. If I make this 1 and then I press the auto, it means that I have selected some external oscillator crystal as a source of my system clock, which then next time if I press this, it will not be programming, because it cannot, the program that I set there, it has changed the source of the pulses for my microcontroller, and it will not work until I put a crystal. I don't know what value for the crystal would be, but I have to find what crystal value is. If I put this checksum 1 here, like 1 1 0 0 would be, and then I have to like connect that crystal to the microcontroller, and then then I can run the program again. The microcontrollers will start working. So right now it is 8 mega internal. Like if I make it 1, it is also internal, but it's in 1 megahertz. So I make it 1, and like it does the programming, but actually the program is a buzzer. I will put the program running. So where is my buzzer? I will put the buzzer on so you can actually see what happens with the this is the ground, and this is the buzzer that I have connected to the program. You can see I put it to work. So right now I am using this 1 megahertz clock cycle. It means 8 times longer clocking time. So I change the fuse bits right now to the 8th one. I take this one off, and then I have to close this, it says. Then I will download this one, see what happens after. The buzzing's time become 8 times shorter because the number of the pulses, the program runs 8 times faster. This is like here, the pulses decide. The pulses decide how many pulses our microcontroller is counting. So we have to put the correct sources. Let me stop this. Let me do it again to be like 1. Close this, and then you will see again become 8 times longer. But I return it to the correct one. Close. This is a code for playing different frequencies with the passive buzzer. This we will do in the class later. So let me deactivate it. That's it, and yeah, that's how you download the program to the microcontroller, and that is. And every time, one time you have you have the ProgISP open. You need only one time in the beginning to like set the clock. You see, I closed it and the clock is lost. The setting is lost. So I did it again. It remembers that it was at mega 32, but it didn't remember that this was the setting was this. So every time you close your program, this ProgISP, and you turn it on, you need to set this fuse bit. But if you haven't closed this will remember the everything that you have set. So you just press the program, the auto, and it will load the program to the microcontroller. That's all that we needed to know. And let's see what happens in the practice. I expect a lot of problems, but maybe not. Maybe everybody can like get this done very easily. Okay, thanks for the attention, and I'll see you in the class. Mhm.